So now we can come back to this question that I asked you in the beginning. And so now somebody should be able to tell me, maybe not all the numbers in the matrix, but you should be able to write down a sequence, just like the game we were playing, that can produce this function, right? That causes these vertices to move to those vertices. So somebody write it down for me in chat. What's a sequence of these things? Maybe add some numbers in there. So I know translate, rotate, scale by how much. You can just use TRS. And maybe write the time symbol when you write it down to make explicit that we're multiplying some matrices. So what's it going to be? I just learned that you guys hate the breakout rooms, so don't make me stick you back there. Somebody in the class can get an answer. Okay, so we're going to do a scale. Yeah, your scale has only one number in it. So I'm seeing in the second chat back this scale 1.5. We should have two numbers. We have a scale in X and a scale in Y, because we have a non-uniform scale happening here. So if we did the scale, and then we did a translate by 1, 3, and then a rotate, no, you're gonna, that rotate is not 45. Ah, I see we need to build up some operations here. Okay, so we still have some confusion surrounding what's going on. So let me, we're going to lose it when we go back to the camera, but let me go back to the camera for a minute because I see that people are still a little bit confused by what's going on here. Okay, so here's our starting position of our house. Oh, let's see here. I don't know that I'm going to draw this exactly like the thing that was going on. So here's our house. And then we went to a new coordinate system, and it was moved over something like this, where it was squished and moved over and rotated, right? Some kind of thing like this. I don't remember if this is exactly right. So now what do we have to do? So we seem to have some different orders that people have, that we have to do this. So do we want to translate first, rotate first, or scale first? Well, remember, once we translate something, so here's our house. If we do the translate first and we get out here, then when we start scaling, it's going to move this thing. And when we start rotating, it's not going to just rotate in place here. It's going to rotate around the origin. So if I have my house out here and I say to rotate by 90, right, it's going to move along the circular arc and it's going to end up down here, rotated by 90. So a typical thing for this kind of problem is if we have something that's on the origin, maybe we're going to do our rotates and scales first because we're already somehow stuck at this point. So let's go ahead and let's do our scale first so that we can get this squished. So the first thing we're going to do is we're going to do a scale, and X, it looks like, got half as big. So we have a scale by 0.5 in X. And it looks like Y went up by 1.5. So we're going to have a scale by 0.5, 1.5 like this. Remember, this thing is a matrix. So then next, we wish we can rotate. And we're going to have to rotate by 90 to get this, right? We want to rotate by 90 degrees to get to here. So this is going to be my next matrix. Now, is this the only answer? No, this is not the only answer. We could have some different sets of things that are going to produce this. And then we have to move up. So in this case, we want this origin point to move up to here. So we're going to have to go 2 by 4. So translate 2 by 4. Something like this, in order to move up into the top location. Now this whole thing multiplies into some matrix M, right? When we multiply, if we multiply matrices times each other, you get back more matrices. So this is a matrix M. Now, could somebody write down some other order of operations? Oh yeah, sure. In fact, we can try to do it. So let's take our rotate first. So I'm going to take my rotate first by 90. And then I'm going to take my scale next. So now instead of scaling x by 0.5, I need to scale my y by 0.5. So I've now got different numbers inside my matrix. Instead of 0.5, 1.5 is now 1.5, 0.5. And then my translation is going to remain the same in this case. We could also move the translate first. We could have other sets of things. But if I multiply this out and get m, and I multiply this out, I also get m. Both of these things multiply to m. The matrix which does this is a unique single matrix. The set of things that I write down to compose that matrix may be changing around. Okay, now let's flip back to our problem. Okay, so now here's the actual problem. Did I draw the same thing? I got it a little bit differently, but you now don't have my page. So now who's got an answer for me? Is one of the answers on the screen, right? I don't see a correct answer, I don't think. Yes, the last one that Aaron put, I believe, is a correct answer to this problem. So you're going to get more practice doing these. There's going to be some of them in the homework, and you're going to get a lot of practice while you're trying to make your example assignment.